Hello and welcome. This is a video lecture review for the textbook, A Practical Guide to Digital Forensics. This is a Pearson-owned and published textbook. ISBN number 13, number 9780137459759. The important part to point out is this is a lecture review using their official PowerPoints. They own the copyright to all of this material. I am just preparing a video lecture for the slides which they provided. They own all copyright information. All information is Pearson VUE. Again, I'm just doing a lecture review. With that said, let's go ahead and jump right on in. Welcome to Chapter 2, the Windows Operating System and the File System. So the objectives for this lesson are to explain what the OS does, explain the binaries, decimals, and other numbering systems and how to convert each of the notations. We're going to look at the physical structure of the long-term storage, i.e. the hard drive, and how files are stored and retrieved. We're going to look at the boot process. We're going to look at the Windows file system structure. We're going to look at the different features of each of the Windows operating systems and their implications for a digital forensics investigation at a very high level. Alright, so what is an operating system? So a strong foundation in an OS is basically the building blocks in becoming a forensics investigator. An operating system is the underlying software running the hardware. It actually acts as the intermediary between us, the user, and the hardware. So we have the user, and they interact with the operating system, and that interacts with the hardware. The evidence that the forensics investigator work with are data files or digital evidence. That could be folders and files, also known as basically just objects. The organizations of these files and data, their location, the metadata, the operating system, and the associated file system that they work on collectively make up the digital evidence on the digital device. The type of operating system and the file structure determines the way the evidence is stored on the device. That also dictates how the data is acquired and then will be analyzed in terms of both the software and the hardware. The different devices have different layouts, so we have to be made more aware of them. A file system is the hierarchy of the files and their respective directories. It's the structure of the hard drive. A data file on a computer is merely a physical impression of data on a metal platter, assuming a traditional hard drive. It could be stored electronic in a flash memory chip if it's an SSD, or other electronically stored device that is not on a mechanical platter. Computer scientists represent the underlying data of the hard drive in a number of ways, normally in a binary format, 1 and 0. Is there electricity? Is there not? Binary, yes or no. 2 states, there is electricity or no, there is not electricity, 1 and 0. Here's the physical layout of a mechanical drive. One of many types. We have power, we have jumpers, and we have some type of interface. This is a dated photo because it's using a traditional SCSI adapter, so like this is kind of dated. But again, general physical disks are laid out the same way. We have platters, that will be the actual metal disk. We have a spindle, which is the middle portion that allows the disk to spin. We have a read-write head that actually reads the data on our platter. we have some type of data connection to our arm. We have an actuator arm, and then we have the actual actuator. So this portion moves the arm over the sector so it could read the different data bits on all parts of the platter. The platter actually is organized and data is stored. And each one of these has X amount of data that the read-write head will actually position itself and read. Again, this is a physical layout of a physical hard drive, mechanical hard drive. Mechanical. The mechanical portion, because it has platters. Metal platters. It's a metal disk. That's one type. We have other types that are just storage memory chips, which is slightly different than this type of device. Alright, so looking at the top-down view of the spindle and platters, we need to then look at a side view. So again, each of the platters are broken up into multiple segments. So each platter will have multiple tracks and sectors. So I'm going to grab my pen. So a track will go around the disk. Those are tracks. And a sector is going to be a wedge. And so a specific section, a track sector, will be a specific sector, a specific track within a sector. That way we can uniquely identify this part or that part, or we can uniquely identify each of the categories. And that's going to be true for every single platter. And you're going to have a read-write head go into each one of these platters to be able to read data to and from them. Remember that the data is stored as binary bits. Binary bits. Recognized as a little b. Forensics investigators need to convert from different formats based off of the forensic software that is being used. There's going to be lots of different formatting that is used, so you have to understand that portion of it. Some files or data on a computer will be stored in binary. So you have to convert the data from binary to something more readable. Binary is composed of bits with a little b. Bits can only have two values, 0 or 1. 1 is a positive charge, 0 is a negative charge. And we can take these binary bits and we can convert them to a different numbering system like decimal or hexadecimal. So the big ones are binary, decimal, hex. So this is base 2, base 10, base 16. And we can represent all numbers. Hexadecimal is base 16, and so that will be numbers 0 through 9 as a single character. When we get to 10, that's 2 characters. So we want to have a single representation of the number 10. So we do 10 as represented by A, B, 12 is C, 13 is D, 14 is E, 15 is F. So these are going to be our hexadecimal. But wait, I thought I said 16 symbols. 0 through 9, that's 10 symbols. A through F are 6 additional. So 0 through F represent 16 separate symbols. So when we start with 0, we have to include that. Most computer forensics imaging software will also include a hex editor that allows us to forensically look at data files in both binary and hexadecimal. Those are going to be two of the big ones that we're going to be looking through. So now that we at least have an understanding of how the data is represented on the platters, we can talk about the boot process. So the boot process is how the operating system actually loads. You hit the power button, and then how does it actually get connected? How does it actually turn on? And that's part of that process. So again, the operating system is a set of programs used to control and manage the hardware and the resources. The user interacts with this through the operating system. When a user starts the computer, it boots. And basically, the operating system records these events. When the computer is powered on, it will go through a power on self-test post. After that, it will execute code stored in its read-only memory. That's referred to as the system's BIOS, or basic input-output system. This executable code will say how to start the next process. And that will be to load the boot drivers. The boot driver will have a specific path that says this is where you initialize the operating system or the system devices. The bootstrap is the process of running the small code to activate other parts of the operating system during the boot process. In the examination of a computer for device or evidence collection for the device, the computer investigator will remove the suspect's hard drive and will clone it or image it. This is actually data acquisition, but we also have to be extremely careful here because removing the device to clone it, we need to ensure we do not manipulate or alter the drive in any way. So we will use what's called a write blocker to ensure that there is no collection of data that is incorrectly done, or alterations of that data is incorrectly done. So what does that mean exactly? If I take the hard drive of a suspect's computer and I image it and I accidentally alter it, case done, case is over. I've contaminated the evidence. So I need to be able to clone it in such a way where I cannot manipulate it. And that's where a write blocker comes into play. And we'll talk about write blockers later in the material, but the important part is with the cloning or imaging, there is specific hardware or software that will be used to ensure you cannot do anything. That way, you don't have to worry about any type of manipulation of that data. Alright, so we talked about how the computer turns on. We talked about the loading of the operating system from the pressing of the power button all the way through the computer actually loading Windows. But what's the structure of Windows? And so that's actually the next section. Once it lets me change slides, there we go. So Windows is the more modern operating system done by Microsoft. It provides a graphical user interface, or a GUI, graphical user interface. And right now, we're talking Windows 11, Windows 12, and those are the big ones, Windows 10. Those are all the variations of the Windows operating system. Each Windows machine, regardless, however, actually has a structure on the long-term storage that's known as the file system. And currently there are several iterations of the different file systems. NTFS, or New Technology File System. We have 4 variations of FAT. FAT64, FAT32, FAT16, FAT12. And that's just for the Windows operating system. Now keep in mind, this is not an exhaustive list. If you have long-term storage, like a USB drive, if you have short-term storage, like a USB drive, that's going to have exFAT. That's not one of the FATs that we have up here. But FAT, or File Allocation Table, is a tool developed by Microsoft, or a file system developed by Microsoft, that utilizes a table to store information, and they have some limits on the size of the files and how many files you can have and things like that. Where NTFS replaced FAT, the more common FATs, FAT12, 16, 32, and 64. And NTFS is the primary version of file system that Windows uses. Not the only one, but that's the primary one. And there are newer ones other than NTFS on the server side, but as a computer forensic specialist, you're probably not going to be tackling the server side of computers. You're going to probably be focusing on desktops. So we also have a different structure. So file systems are the way the data is stored. What about the way the settings are stored? And that would actually be the Windows registry. This is a hierarchy database that stores system configuration information, and it maintains file groups used to control their operating system. It has things like hardware, user details, preferences for opening this file extension. This is going to be the structure for all the configuration settings. In terms of evidence, the registry can provide a large wealth of information, including internet searches, sites visited, passwords, and common user activities in conjunction with other items. The registry has 2 main elements, a key and a value. A key is basically like a folder that allows us to easily identify by noting a folder icon, and most keys will have subkeys or subfolders, and the subfolders can have multiple subkeys and so forth, so a folder inside of a folder. And then we have the value, which is actually the data inside the folder. So most people are familiar with like a Word document inside of a folder. The key is the folder, the value is the data inside the folder. The Windows registry has 5 basic groups, also known as hives, which play an important role. Those hives are hive key, class root, current user, local machine, user, and current configuration. And there's a structure to the Windows registry which is outside the scope of this early of a course. Right now, we're just talking about basic foundation, and that's really it. So we will get deeper into the hives, just not yet. Alright, so let's explore it a little bit more. So here we have our hive keys and subkeys. Actually, I'm going to grab my mouse, my pen. So here we have a little caret next to each one of them. Those are the primary hives or folder. And then inside of each folder, we have subfolder or subkeys. And inside each subkey, we have files. And we could have a reg-d word or reg-hex word, or we're going to have different types of data types in here. And this is actually what holds our settings. And then down here, we can actually see the path. The computer, that's the name of it. The HKey_current configuration, software, / where in fonts. And inside this folder are those values or data. So oftentimes people go, oh, well, I don't have to interact with this. Well, when you make a change, like a network setting change or a control panel setting change or any type of main settings, well, guess what? You're actually dealing with a graphical user interface that modifies the registry. So you don't have to. For example, when you're in control panel and you change your right-handed mouse to a left-handed mouse, what it does is it updates one binary bit in the registry that modifies it so that it becomes a left mouse. You did it through control panel, but control panel just interfaces back with the registry. So moving past that, we have other Windows features. Event Viewer is a log tool that will log everything. When you turn it on, when you log in, when you think too hard, we have an event viewer that will view all of our logs. We have a defragmentation tool, we have a ReadyBoost tool. Windows has a ton of built-in information that is readily available. You have to understand what tools are in the operating system for you to interface with. Out of this entire list, the Event Viewer is probably the first one that you'd want to learn. Then the Registry Analysis tool will probably be the second tool. Here we have we're not going to cover tool by tool, but we're just going to cover some of them. So here's our disk defragmenter. If you were using a mechanical disk, you'd have this. However, here we have a Western Digital USB drive. It was never ran. Because in reality, on storage media like USB or SSDs, you're not going to run the defragger. On a mechanical drive, you would. So you're going to end up with viewing the disk defragmenter tool less and less and less. Here's our event viewer. Here are where our logs are. And when you would actually dive into it, you could see all of the system logs for the security settings, the applications, for pretty much everything. All of that will be stored in that log section. And then we have our system restore. If we're using that as a way to restore our settings, we have a private browser with Internet Explorer that's now been replaced with Edge. So again, that's what I mean by tools change. So sometimes you need to understand the process, not so much the specific technology. Because in private browsing, that's still around. Internet Explorer, no. Edge, yes. So understand the tool or understand the process. If you're going to understand the process, you can apply it to multiple tools. Alright, so we talked about an operating system, reviewed the binary, decimal, hexadecimal, and it did not show us how to convert them. We will be doing later videos on conversion. We also have the physical structure of a hard drive, the boot process, Windows file systems, and feature set. So that makes up our Chapter 2. If you have any questions or issues or thoughts, please let me know. Thank you. Alright, that concludes our lecture review. If you have any questions or concerns or anything, please feel free to reach out. Again, communication is kind of important. You being able to at least discuss, hey, I have this type of question, let me know so that I can figure out a good solution. Thank you.